Welcome back to Nature of Code in Rust and GGEZ. In this video, we're going to be going over exercise 2.3. Instead of the objects bouncing off the edge of the wall, create an example in which an invisible force pushes back on the objects to keep them in the window. Can you weight the force according to how far the object is from the edge? As in, the closer it is, the stronger the force. So let's take a look at what we have here. So if we run this exercise, this is a copy of the last example. We have our balls with the different masses with a steady wind applied to them, and they're all moving to the right, and then they bounce off the end wall. So this exercise is to replace that bouncing off the end wall with some kind of force that's going to push them backwards. So let's go ahead and see what that might end up looking like. We're going to go into the mover class, and where we have the bouncing off, we're just going to replace this here. So we need some kind of force. And what I'm thinking of, we want to get an exact force of where it is on the x-axis and pushing to the left. So if I get the exact distance to the left-hand wall, so basically a vector of exactly where it is in the y, but with a 0 value, so of x. Let's just create that. Let's create like left wall. And this is going to be equal to a new vector 2, 0.0 for the x, and self.location.y for our y. So that gives us, basically we now have a vector all the way in the left-hand wall with the same height. And then if I can now get the distance, between those vectors, the vector actually is representative of that distance or difference. So we're going to call this force. I'm going to make it mutable because we're going to normalize it and scale it. Equals to, this is going to be our left wall minus self.location. Okay, so then we're going to normalize this. So force normalize. And now we can scale this up by some amount. So we'll probably do some kind of like, no, not that. Force dot multiply scalar, and we need some kind of scalar, whatever this is going to be. Well, I'm thinking before we normalize this, we can actually get the distance here. So distance equals our force. We can get the magnitude of that, and let's scale it so that it's dynamic. The farther we are away from the left-hand wall, the stronger the amount is. What we can do is just take this number and multiply it by some amount. So something like 0.001, for example. And then we're going to multiply by this distance. Then finally, we can't forget to actually apply this. So self.apply force with our reference to the force. So if we run this exactly as is, let's see what happens. It feels like it's moving. Oh yeah, definitely. That force from the right-hand side, which is really just a measure of how far it is from the left, is unfortunately really strong. So I think what we need to do is add 1 or 2 zeros. Let's add 1 0 and see how this feels. So as the steady wind is able to continue the forces on it, it actually gains momentum, is able to continue fighting through this increasing force on the right-hand side. But as that force just becomes more and more powerful, we see that it actually becomes strong enough to push them back to the left. And then once it has that momentum going left, that force continuing to sort of like tap it every single frame, it makes it come almost all the way back to the right again. Now it's still hitting the right-hand side. I tried playing with the numbers to get just to tweak it perfectly. I think I'd have to tweak the wind too to get it working exactly the way we want to. But I'm going to consider that this is pretty much done. It's not going past the right-hand side. It's just just coming right up to the edge of it. So that is exercise 2.3, a dynamic force based upon how close or far away the object is from something. I'll see you in the next video. Thanks for watching. Bye.